Come on.
Oh, live. This isn't even like recorded and uploaded. Good stuff. All
Yeah.
right. You ready?
Yeah, go for it.
All right, folks. So today I'm going to talk about something easy and simple, reference architectures. So these are GitLab's architectures, and a couple things today we're going to cover are just I want to cover some key concepts, uh, talk about single node versus HA, when to use them. We're going to go through some GitLab components on the servers. So when we get into the slides later, you'll see that GitLab's quite a complex stack with a lot of pieces. And so I just want to talk through each piece and what its function is. And then we'll start talking about the reference architectures themselves. So we'll look at a traditional 3K, a cloud 3K using cloud services, cloud native hybrid 3K. And then we'll move on to GitLab GEO, talk about that, what it's used for, what it does and does not do. And then the final slide is just a getting started with Git. And I think there's another enablement session that'll actually get into the details of how to deploy a reference architecture. Please feel free to ask questions and interrupt as we go along as well. Um, So the first thing, and Brian put this in, I think this is a good slide just to start with real quick, but GitLab has three offerings. We do self-managed, which is what we're going to focus on today. And then we also have a GitLab dedicated, which is self-managed, but GitLab dedicates it. And then GitLab.com, which is our SaaS offering. All right, key concepts. So the first thing I want to discuss is Omnibus, and I think that gets thrown around, and sometimes folks get confused when we use it. But what Omnibus is it's GitLab's bundled package. So it includes all the installers for all the services that we talk about today, and a few that I didn't include because they're not as commonly used. So when you install GitLab on servers, you get one file. It's an RPM or YAML file, and that one file can be used to install any service, Redis, a Postgres, and we'll get into all of them later. And how it works is you install the YAML file, and then there's a configuration file called the GitLab RB, which is in etc GitLab, GitLab.rb. And the configurations that you make in there determine what that node is and how that node gets configured. So I'm going to pull up an example real quick. And this is what I use when I'm trying to figure out how a service gets configured. So this is, I don't remember how many lines of code, it's huge, but let's say you wanted to install Postgres. If you go into this file and you uncomment out Postgres enabled equals true, this node now installs Postgres. And alternatively, you have to tell it not to install services too, right? So if you don't want Postgres, you would have to set Postgres to false. High availability. So high availability is your infrastructure being designed in a way that can tolerate outages without degradation or performance hits. So with GitLab, we can deploy within region high availability, but we cannot do high availability outside the region without a loss of uptime. And we'll get into that when we talk about GEO and what GEO does and its limitations. The other thing I want to discuss here too is when QA does the reference architectures, they use the expression double double, meaning when you talk to Grant, for instance, he'll say that our reference architectures are double double. If we say it's a 2K reference architecture, it can support 8,000 users more than likely on a standard load. But the idea is that if we want HA, we want to make sure that we can tolerate outages without degradation of performance. So if half of our infrastructure goes down, we don't want the other half getting hammered by the users. We want them to still feel like there's up and running and everything's good. So our for most standard customers, our reference architectures are overkill. They are very large, but they're intentionally designed that way so that they meet the HA qualifications requirements. And then DR is how we handle catastrophic outages, right? So if you're in AWS, for instance, what happens if Virginia falls in the ocean? Um, that's where everything's stored. That's Netflix, right? So how does the customer get their source back? And GitLab solves this problem with GEO. And I think a lot of times customers get confused between HA and DR and what requirements and what GitLab products solve for those problems. And then the only other two things I want to cover that come up a lot in calls with customers is RPO and RTO. So RPO, the recovery point objective, is in a disaster scenario, what is the recovery point in time that we can hit? right? So if you think about nightly backups, for instance, if you're running a backup nightly, your recovery point in time has to be 24 hours because you're only running one backup of that instance every 24 hours. If you're doing hourly snapshots, you can hit a, 1 hour RPO. So, and if you use GEO, and we'll talk about this later, your RPO is closer to 15 minutes or real time because you're constantly streaming that data to another region. Recovery time objective is the maximum amount of time that your organization can be down until you've recovered. So how long does it take your SREs to get GitLab back up and running as soon as there's outage? Any questions on these?
Nope.
Cool. All right. I think the next slide kind of talks about it a little bit more, and we'll go into it. But there's trade-offs when you talk about RTO and RPO. The lower those numbers are, meaning the less data loss you're willing to accept and the faster you want to be up, the more expensive the infrastructure is. So simple disaster recovery approaches are less costly, but carry a higher risk of data loss and system unavailability. And we'll talk about that here. So I want to kind of talk about a single node versus a reference architecture, right? And Brian put together a slide to talk about this. It's like a table. I like images. So I put together a network diagram. This is a 3K reference architecture with a 3K GEO. And this is about $60,000 worth of VMs up front. And I'll kind of get into the cost and things like that, how that works later. But, if a customer comes to us and they say that we need a 3K reference architecture and it has to be highly available, and we want a 3K reference architecture that's highly available in the secondary region, they're asking for 50 servers and $60,000 worth of upfront VM costs for the first year. So, the RTO and the RPO are great with the solution, but it's also incredibly expensive and you have to have the staff to support it. For environments serving 2,000 or fewer users, GitLab actually recommends a single node. So if you go to the reference architecture documentation, I think professional services historically has used the 1,000 user marker, but GitLab as a QA organization recommends 2K. And then just kind of go through the advantages. So if you look at the left side, this is your primary site, and you look at the right side, this is your secondary geo site. Either one of these can be a single node and support up to 2,000 users. So, by going with a single node geo, for instance, you're taking out a considerable amount of infrastructure, but you're giving yourself much easier infrastructure to manage and set up. You can use GitLab backups and snapshots at the same time. And, the downside is you have a single point of failure. Sorry. Any questions on HA? And we'll get into the actual components and what they do.
Out of curiosity, do we have an idea how much of this total infrastructure is represented by the database, the Postgre infrastructure?
Yeah, I'll get into the components another slide, but absolutely. So this is the front end. So your web servers, this is your Sidekick, your background jobs.
Mhm.
This is your application database, these 6 servers right here. This is your cache database. This is your failover, Sentinel, and console. And then there's another database over for Gitly cluster. And then on your secondary site, there's an additional database for tracking database for GEO. So a lot of databases involved.
Yeah. I'm just thinking that maybe more modern databases might provide some efficiency in this area, but that's just a wild thought, right?
Nope, you're not wrong. We'll get to that. Awesome. Okay.
Kevin, on the
Yes, sir.
on the secondary site, how hot is that? How hot is it in order to fail over? How long does it take?
I'll cover that later, but it could be done in 15 minutes.
Okay. Can you run active?
No. Yes and no. And I'll cover that later.
All right, you're going more into
I'll get into that. Yeah, we'll talk about GEO at the end. When you talk to customers, though, yeah, we'll get into that in a later slide. I don't want to undercut it, but very good question. So, I'm just going to spend some time going through the different services that run on these, just so everybody knows. These are the front end services. Sidekick probably shouldn't be on this list. I kind of group it with it, and we'll talk about that later with Kubernetes. You know, but if a customer comes to us and they say, hey, we want to run GitLab and Kubernetes, these are the components that essentially get put into Kubernetes. So, and then there's a diagram here on the architecture site, and we're talking about these groups right here. And they're usually all on the same node, or in some cases, split up. So we have Puma, which used to be called Unicorn, and that's our front-end web server. So Puma is, when you go to gitlab.com and you see the GUI, that's Puma rendering that for you. And then we have a service called GitLab Shell, and GitLab Shell is where all the Git operations over SSH are managed. So for instance, if you clone a repository with a key pair, that's going to be run through GitLab Shell. Workhorse is a reverse proxy load balancer, and it handles a lot of the large or long-running operations. So if you look at this chart here, you can actually see that everything goes through Workhorse before it goes to the web server. It kind of decides what goes to the web server and what doesn't. And the example that I'll give is and it might have changed, it's been a while, but object storage used to go from Workhorse directly to S3, right? So if you wanted to check the logs on objects not being uploaded to S3, the Workhorse logs would house that. You wouldn't necessarily want your web server handling a large tar file. We use Nginx in the front end too. So Nginx sits in front of everything, all web-related stuff, and determines if something's going to GitLab pages or if it's going to Workhorse, and then your certificates are configured at Nginx rules if you need them. GitLab pages, GitLab can serve static pages, and they're served from S3 or object storage. And then finally, Sidekick, which is a background processor. So Sidekick jobs are stored in Redis, and the example I like to give, and I don't know if this is still the case, but when you think of an action in GitLab, like if you delete a user, GitLab doesn't go and delete the user. It creates a background job in Redis that says, hey, this user is to be deleted. And then there is Sidekick processes that are picking up these jobs and deleting these users. It's very similar to how like SQS and AWS would work. Any questions on the front end services? Okay, back end. So we got Gitly, and this is where all your source code is stored. It used to also store snippets. It may still, but your actual source code, that's on the Gitly nodes. We have Prefect. So Prefect shows up in our 3K architectures and higher, and it's for high availability. So Prefect does things like, ensuring that there's replication on the Gitly nodes, load balancing, failure recover, data integrity. When a user makes a commit, what Prefect will do, if you have 3 Gitly nodes, Prefect will write that to 2 if that's what your replication factor is, and then check the hash to make sure that there's strong consistency across the 2, and then mark that as both nodes were written at the same time. If one node fails to write, so you have an outdated version of the repository on one node and the other node, for whatever reason, is up to date, it'll flag that node and put a background job in to go back and make sure that gets replicated. We have Redis. So Redis does all of our caching. It does data caching. So it's used to to store frequently accessed data to reduce load in the database. You can think of things like user information, project metadata, repository data. It does page caching. So certain pages are cached up to reduce or increase the rendering speed if they're frequently accessed. It houses our background jobs, and then it manages session management. So when a user logs into GitLab, Redis is what makes sure that their session state is held, as their load balancer might be moving them to different front-end nodes. Console. And just remember, when we showed that diagram before, all of those are these components broken up into different servers. So, when we talk about the complexity of GitLab, it's because there's so many services that have to be installed. But console is delivered as both a client and a server service. And it's used for 2 things. It's used for monitoring. So it'll collect Prometheus data that can be graphed with Grafana, which used to be shipped with GitLab. It also will keep an eye on the health of the Postgres node and elect a new leader. So if we're deploying our own Postgres solution in a high availability scenario, then console would go with it. Sentinel is very much like console. It monitors Redis. Redis Health and elects new Redis leaders. Prometheus is for metrics. So we have two pieces that we install. There's exporters and there's the Prometheus server. And the exporters will gather metrics on GitLab services and send them in so we can have our graphs and dashboards to make sure that we're monitoring GitLab. The database. So we use Postgres in a lot of different areas in GitLab. There's, you can have it for your application. You have to have one for your application database. If you have Gitly cluster, you have to have a Gitly cluster database. And then every GEO site has to have Postgres. And, just funny story, when I started, we actually supported MySQL and Postgres, but that just slowly was phased out. And then the last two servers on here are in support of Postgres. So PG Bouncer helps us with database pooling or connection pooling for the database, and then along with the load balance configuration. And then Patroni supports the failover activities alongside console and PG Bouncer. So go right into talking through a reference architecture. So this is GitLab's 3K reference architecture. I think for the EMs always ask, why does an implementation with GitLab cost so much? Or why is there so much time that needs to happen with it? And it's because GitLab HA is complex. So in this scenario, we've got 25 servers, 2 load balancers. There's 8 S3 buckets. In those buckets, artifacts, external diffs, uploads, LFS, packages, dependency proxy, Terraform, and pages. And when we talked about the front-end components, we were talking about these components right here. All of these represent our back-end components. And we actually have a cost and calculator available now. So that's where I got this from. So if a customer says, how much is this going to cost to deploy? You can go here and share that cost. In this example, it is $29,000 just to deploy the VMs on AWS for a 3K reference architecture. This is not data storage. This is not network traffic, ingress and egress. This is just straight up the VM size to spec.
So Kevin, this is the cost. Amazon, this is the cloud cost.
Yes, sir.
Yeah. So you got then new subscriptions all on top of this, and obviously,
Yeah. And it kind of goes back to that slide earlier. When you start looking at RTO and RPO and you want better results and customers want HA, it's expensive. So this is the first 3K is where full HA starts with GitLab, where you have Gitly cluster. So when customers come to us and they say, okay, we have 50 developers, but we need HA. Sometimes I don't think they understand that, okay, but can you manage 25 servers and take on $30,000 in VM costs? Is that worth HA for you? Or is a single node, with a single node GEO, which we'll talk about later, the right solution?
And just finally, does the level of subscription have an impact on this design? Ultimate feature, did that add more computation power maybe?
No. No, the biggest drivers for Ultimate have historically been plan and secure.
Yeah.
But no, I mean, this is when a customer says, hey, I need HA, this is entry level HA. This is what they're asking for.
Okay, cool.
And you can deploy this on GitLab's free product, but we don't support it. So we've had customers come and try to engage PS when they were on GitLab free, and we don't want to help them build out something that normally would be a paid tier. This is something they have to do on their own. I kind of want to show you what deploying to AWS and cloud services can bring to the table, though. So with AWS customers, and the GitLab Environment Toolkit supports this, we can use services like Elasticache and RDS to significantly reduce the footprint. So we just took 12 servers out of the mix just by saying, hey, I want to manage Redis service Elasticache. So give me an HA Redis cluster. And then the same goes to RDS. I want a multi-AZ RDS instance. So pretty significant reduction in nodes. And then the next thing I want to point out too is when a customer comes to us and says, I want to deploy with Kubernetes. This section here is what's in Kubernetes. All of these still have to be VMs. Now you can deploy these other servers in Helm, but the documentation says that it's alpha. It might be beta now, but it's not supported in a production environment, and they should not be running these components in Helm for their GitLab production deployment. The only servers that go into production are these front-end nodes here. So when we talk to customers, again, going back to the smaller user counts, they might have 50 users, 100 users, and they say, hey, I want to run Kubernetes. What they're really saying is I still want to have, what is this, 18 VMs for my 12 users, but I want to add a Kubernetes stack on top of that and manage that as well. And we try to discourage that until they get into the much larger range. I think the QA team recommends folks be at 3K or higher. Professional services has seen success with folks at 10,000 or higher with a dedicated Kubernetes team. And I'll kind of show you in a little bit the advantages that Kubernetes brings to the table. But the biggest disadvantage is that you also cannot do zero downtime upgrades with Kubernetes. So, any questions? Okay. So one of the things we're learning with customers, and this is where I got to not say names, but traditionally we've always scoped architectures based off user count. You have 2,000 developers. This is the reference architecture for 2,000 users, and that worked very well for a long time. But we have customers that are kind of using GitLab in out of the box ways. It's an automation tool with a lot of power. And, we had one scenario where they had 3,000 users, but they were using 25,000 users worth of load on the system. And so when we're scoping these are the types of ones we want to ask the right questions. Why do you need to expand your GitLab footprint? Why are you moving to the cloud? What are you running on today? How is it performing today? And if we start to run into scenarios where we feel like a customer might be using more than the standard, that's something where we would want to do some discovery and get fast stats and actually start looking at the requests per second from their live production data, than just saying, hey, here's a 3,000 user architecture. And you'll notice with Kubernetes, it actually supports double the requests per second for the infrastructure. So one of the advantages to Kubernetes is that it can scale those front end, API type servers very quickly, the ones that handle the Git traffic and things like that. So you lose zero downtime upgrades, complexity goes up, but you do get better performance as a whole. And I shared the link in the notes for this for Fast Stats, which is a tool that you can use to collect this data. Any questions on this one? And then we'll get into GEO. Cool. All right. So GEO. So GEO can act and look like the primary for geographic distributed users. They don't necessarily know that they're on a GEO node, and users can push and pull from a GEO node. And what happens is that if a user is connected to a GEO node and they do a git push, it actually behind the scenes proxies it to the primary. So if they're on this node over here and they push to it, it proxies it to the primary, which writes it and then replicates it back to the GEO node. And for geographically distributed users, when they pull, it pulls from the GEO node. So if you have, your main site is in Americas, and I actually had a customer like this. They had a data center in Seoul, South Korea, and when they were cloning and fetching large repositories, it was taking forever. And when they stood up a GEO site, that it went from minutes to seconds to pull those repositories. You can balance the read-only traffic too between your primary and secondary sites. We have another customer we're talking to now that does a significant amount of API calls against GitLab. They're looking at standing up GEO, and that is so that they can do other calls against the secondary site. The other thing to note is that GEO can share a URL between your primary and your secondary. So you can have a separate URL for GEO, but you can also have a unified URL and then use some GEO DNS and load balancing to kind of distribute the users where they go. Any questions on what GEO does from a distributed perspective? No? Okay. So you can fail over pretty quickly with GEO. I did it with one customer. They were 15,000 users, and I was nervous, and it happened almost instantaneously. And it's like one command now. It's gotten significantly easier than it used to be. So when a customer wants to fail over, it's just, prepping the environment and running the command and updating DNS, unless it's a unified URL, which in case it'll just work. Runners automatically connect if they're still up and running because the URL is the same and the tokens that they use are in the database. That's a read replica. So you can, with the proper planning, you can fail over very quickly to GEO. One of the limitations that, when folks say, well, why can't we use GEO as an HA solution? And the reason is that the primary authenticates, or the secondaries authenticate off the primary. So if your primary goes down, your GEOs actually go down until you fail over. And so they are not, that's it. Look. So it's just something to make sure you're aware of. Once you fail over, then they totally work. But when you authenticate against the GEO secondary, it actually sends it back to the primary to authenticate. So you lose that functionality if the primary goes down. The other thing I want to call out too is that the GEO secondaries and primary don't care what the other one is. So you can have a single node primary and a 50K reference architecture GEO. Don't do that. That's crazy. But you can have the other way around too. So you can have a 3K reference architecture for your primary site and single nodes on the GEO, and you can have multiple that way. And the only thing that it cares about is there needs to be a read replica of the database, which can be within the single node. This is an AWS diagram, so I have a RDS read replica here, and that the two front ends can talk to each other because they communicate over APIs. And more often than not, you're going to have a smaller GEO depending on your ability to maintain servers. So keep in mind that a 3K reference architecture was 25 servers. A 3K GEO means you're managing 50 servers plus an additional tracking database.
Is there any kind of use case benefits for bi-directional active-active?
So yes and no.
Yes.
Right.
Yeah,
So active to me is if one goes down, the other one works. And we
Well,
don't get
that's
that.
passive.
Okay.
So
Yeah. So
active-active would be you've got two use case, two
you
production loads.
can absolutely use both for sure.
Yeah.
Users, if you've got users all over the world and you want to distribute it, they can use those other sites. Now, a couple of things to keep in mind. They don't necessarily know this, but the writes that they make are actually going back to the primary. So you want to make sure your primary is big enough and to support your secondary nodes. And those secondaries will stop working if the primary goes down until you actually perform a failover.
Yeah. So you always have a primary. You can't have two primaries replicating back to two secondaries across.
Correct. Yeah.
Okay.
And I kind of touched this in the beginning, but with GitLab, within region, within data center, we can support HA, but we really can't support true HA across different regions. The other thing, and it's getting better, but the recovery process from a GEO failover, you have to rebuild the original site. And it might have changed. I could double check the documentation, but historically, let's say that you had a catastrophic outage on your main site and you did the GEO failover and your user is using this. The process to go back would be to stand up a new primary site, set it up as a GEO secondary to your now promoted GEO secondary, let it replicate, then promote your primary site again, and then restand up your GEO secondary, set it up as a GEO secondary to your original primary site, and then let that replicate as well. I mean, you're back up and running. Your users didn't really miss a beat, but as an SRE or an admin, you've got some work ahead of you.
I have a question. What is the typical lag time for data replication? And how do we ensure that data integrity is ensured?
So the data, GEO has, well, the lag time I'll tell you right now is pretty quick. It happens when pushes happen. Usually I find that it's within minutes, if not faster. There's caveats, right? If a customer, I had a customer that for some reason was pushing like ISOs to repositories, which is a whole nother conversation, but that's not the point, right?
Mhm.
If they push a 10 gig ISO to the geosecondary, they just have to be aware that it's not going to write to the geosecondary. It's going to be sent over the primary to write in the primary. And if they're in America and South Korea, that might take a while. And then it's going to replicate to the geosite. So things like that would take a while. But if you think of your average git commit and push, there's not a lot. It's text, right? It's code. It's very quick. It's not like in one commit, I'll push a gig of code. So it's very, very quick. And as far as the consistency goes, GitLab, there's a table, and I'll see if I can find it. I can follow up, but
So can I just add here, Kevin?
yeah.
Yeah, so basically for Geo, there is a dashboard that you can see on the UI itself, and the replication keeps going on. And you can make sure that, that is up to 100%. It'll show you both the primary and the secondary site. And you can just make sure that you see it's in 100% sync, and only once in sync, you can just do the failover. I can probably try seeing if I have my setup on, and I can share a screenshot probably.
Yeah, that would be awesome. And while she's looking at that, let me know. I'll switch the presenter to you. I'll find it. There's a table for the different data types and how she checks consistency. So they use hash. It's validated.
Okay.
The other thing to call out too, especially when we talk about cloud environments, is that Geo will replicate object storage for you. So if you're going from AWS to GCP or something like that, Geo can manage that for you. But more often than not, when you're working in cloud environments like AWS, they have cross-region replication with buckets, and you can also just set that up and let Amazon handle your replication of buckets. Any other questions on Geo?
Just one. So actual use case, can you use Geo? You can use Geo, right, to migrate, can't you? If you've already got a Geo environment running and you want to migrate using Geo, is that limited? Is that a limitation?
Yeah, when
Can you
you
have that another Geo link coming in to do the migration?
it's like hub and spoke. You have your central primary, and you can have as many geo nodes as you want, and they can be as big or small as you want to, right? You
Okay.
can have a 3K reference architecture, and then you can say, I want one single node geo in South Korea, Seoul, and I'm gonna take snapshots of that, and that's just just in case. And then I might put another full 3K on the West Coast if I'm on the East Coast so that I can fail over to that.
Okay, and they could all go into the single instance.
They all go into the single instance. The caveat is that when you fail over to a secondary, all of the other geos become orph. They don't follow.
Yeah, yeah,
So
yeah,
you would want to hook them up.
yeah. Brilliant. Thank you.
And here's the data types and the verification replication method. So it's a pretty cool table. And especially recently, I don't think there's anything that they don't have some kind of strong consistency verification for the data type. This is also a great chart if you're scoping with a customer and they say, does Geo replicate? Because there in the past had been items, or if new object types come into play, like when Terraform state files first came into play, for instance, I don't think it immediately was supported by Geo as a replication type. So if customers ask, hey, can you replicate this type to the secondary site, this table right here, and I'll drop the link in the chat. And then going on to the last slide here, I just wanted to kind of share. I share this with partners too. I think this is pretty cool. Anybody, especially within GitLab, can go check out our GitLab Environment Toolkit. If you need help, I can show you how you can create a cloud account at GitLab. And we have a implementation services learning path, which is free for everybody, GitLab employees and customers. They can go and take this online course that education provides. And then they can run through our hands-on workshop, which I think is internal only, but we do, set it up for partners and things like that, which is a GitLab issue that walks you through deploying a 3K reference architecture in AWS. Just make sure you delete it when you're done because it's $30,000 a year. So any questions on that? Cool. Janice, if you have it, I'll let you show it. If not, we can probably cut it. I don't know.
So I have a screenshot, probably I can show.
Does it have any customer names?
That's what I was checking. No, this is on my sample. So yeah, I can share this.
Okay.
I mean, I have anyway destroyed this environment, so it's okay. But it's just a screenshot. Sharing my screen. Are we recording? Because it's on.
Yeah, it's streaming live to YouTube. Glenn's got us covered.
Okay.
Keep it safe.
I don't want to share probably on the live stream.
That's okay. Let's not. We can stop the recording and then share it. That's fine. I'd rather, like Glenn said, keep it safe than make a mistake.
Yeah, you can just set it offline. Yeah.
Excellent. Thank you, Kevin, very much for that. Any other questions, comments?
It says it's still live on YouTube.
It is. It is.
Okay.
Right.
Yeah.
Before I want to make sure we've got everything covered that we can talk about, and then we'll go to the private portion. So, any other questions, comments? I'll update the documentation. Kevin, you can send me the link to your presentation. I can drop it in there as well. And if anyone has questions that they want to answer, drop them in the doc as a comment, and we can get to those as well. Otherwise, I will stop the live stream portion of this. Thanks again, Kevin, very much. Appreciate it.